So yeah, welcome to day 4. So the idea of this morning is to kind of look a little bit more at some of the Python things we've been learning in the last 2 days, and maybe, yeah, go a little bit off piste of what the traditional Carpentry's material is, and then again, have sort of 2 coffee breaks in the morning, and then move over to version control with Git. I have not tested in terms of how long the planned material will take, so it might well be that we end up starting with Git a little bit earlier, or if you have lots of questions, we can just have a discussion session. So I'm quite flexible with kind of what people's needs are, but I will stick to the scheduled break times. So they will definitely happen. Yeah, so I think I thought I'd start with the script Matthew prepared in the Etherpad. So hopefully you can see my screen, and hopefully you can all get your Jupyter Lab up and running. So if you haven't done that yet, please do that now and give me a green sticker when you have.
Should we continue with yesterday's notebook, or shall we start a new one?
So we're not actually, the first bit, we're not gonna be using a notebook. I just need the Jupyter Lab environment, and it might make sense to start a new notebook just because, I don't know, whatever you prefer. I mean, it's your organization, so I don't really mind how you do it.
Okay, great.
So yeah, mine. Ooh. No. Hello?
Sorry, didn't realize I wasn't on mute. I was talking to the dog.
Oh, right. Yeah, so you should, I don't know, I have a bunch of notebooks open. I will probably actually close. So here's a good way of actually closing them. So shut down kernel, closes your notebooks. If we haven't done that, and then I can just close them here as well. No, or not. Okay, there we go. So I'm back to my launcher, and the first thing I would like for us to do is try and run Python script from the terminal. So in your Jupyter Notebook environment, you also have a terminal button. You can get to that by clicking on the plus here, which will open up a new launcher. And then you should be able to open up a terminal. I'm going to see if I can, I hope you can read this. I have some interesting formatting with my terminal, so this might not be the easiest to read. If you can't, please let me know. And now we can use our bash skills again. So I'm in this directory, well, the Carpentry's directory, and I've prepared a bunch of directories, so notebooks, data, documents. And I don't think you shouldn't have a scripts directory. So if you manage to get to the terminal in your directory you're working on, it would be good to start by creating a directory with mkdir that is something like scripts, which I'm not going to create because I've already, actually I'm going to create the scripts too. So just create a directory like this, and then let's navigate into this directory. And the next thing is let's copy and paste the WAV file writer example into a file to then be able to run this. So I just copy this and then navigate back here, and then I use nano, and let's call it example.py, and then just paste that in. So I now have that in this file, and then write that out and exit the file. Can everyone get to that point?
Sorry, could you just run through the last part again? Because it took me a little while to
Sure.
make the directory and so on. So I've now got my directory.
So I basically just open up a file where I use nano, this editor, which hopefully works for you. Is that what you've been using in the bash part of the workshop?
Yeah, that's right. Yeah.
Yeah. So nano, and then I just type the file name, example, let's call it example2.py, py extension for a Python script. And then I just have an empty file. And then I just went to the Carpentry's Etherpad and just copied and pasted the WAV example from Matthew. So just a copy or Control-C, whatever you prefer. And then I go back to my nano and do a Control-V paste into it. And then in order to write out, I use Control-O. Now it asks me, do I want to write to file? Yes. And then Control-X will exit this editor again.
I'm having some trouble. Control-V doesn't seem to be working for me on Windows.
Interesting. I mean, if you find is there a way for you to create that file with a different editor, maybe in that same directory?
Yeah, okay, I'll do that. Thank you.
Yeah, sorry. I mean, this is just, I'm trying to keep it all within the environment we're using, but it might be tricky. Does everyone manage to create this example.py file? I've got one thumbs up. Can I get some more thumbs up? Or if you're struggling, can you tell me what you're struggling with?
Currently scrolling through the Etherpad trying to find the WAV.
It is line 200. Hang on, where was it?
Got it. It's 225.
225. Yeah. Maybe I copied something else. I'm not really sure why I copied. Two, 5. Yeah, 225. Okay, there seems to be multiple versions, but anyway, that's 225 is the one I would like you to try and do. So when you have managed to get line 225, you can run the script by writing just, actually I need to, sorry. You don't need to do this. This is just something I need to do. So in my directory, I now have this example.py file, so I can just type Python example.py, and that should run it. But it doesn't. Does everyone else get the same error?
I'm getting a slightly different error.
What's your error?
It's an invalid syntax error. Just after. Oh, is it possible that if I just if I typed Python, it's running it in Python 2 rather than Python?
So if you type which Python,
Yeah.
which
Okay.
Python will tell you which Python you're running. And for me, this means it's this Jupyter Lab environment I created. Or you can type Python -- version. Oops, not 3.
Oh yeah, it's 2.7.16.
So you're using your system, you're on a Mac, right?
Yeah.
Yeah, so you're using your system Python. That's interesting. Are you doing this in the Jupyter Lab environment?
Yeah, I am. And usually when I open a notebook in Jupyter Lab, the default is Python 3. So I don't know why it's doing this.
That is, can you actually share your screen briefly?
Yeah, sure. Can you see that? Okay.
Yes, I can see this. Interesting.
So I think I could just try doing Python 3 example. Might that work? I think I've had.
Well, it's not picking up your Anaconda installation. Can you open up a different terminal?
Can I do it this way? Okay.
No, I think that should be, well, try that. I think that should give you the same, to be fair.
Oh, right. Oh, you mean a terminal like from?
Yeah, like a computer terminal.
Yeah, I'll do that. Can you see this one that I just opened?
I can see this, yeah.
Okay.
Can you now type Python -- version again? Okay. So if you navigate to your Carpentry directory where you've put the example py.
Okay. Let's see. I put it in here. Oh, maybe it's in scripts.
Yeah.
No, that was.
Yeah.
Oh yeah, it is in here.
Yeah. So if you now type Python space example.py.
Oh, that's the same.
You get the same error. Wonderful. That's exactly what I wanted.
So
So
stop sharing.
Yeah, you can stop sharing.
Okay. Thank you.
So I'm going to start sharing again.
Can I just ask a quick question? Sorry.
Yes, absolutely.
When I try to save the script, I press Shift and X to exit the nano, or at least that's what I'm intending to do, and then press Y to select yes to like save the changes, and then it gives me like a lot of options, which yeah, I'm not sure basically which one to select. I think I tried save to file and then it did something a bit strange, so I'm not entirely sure what to do next.
So you didn't manage to save the file?
That's right, yeah.
What if you hit Control O? Does that give you the option?
Hang on a sec.
I mean, it might be easier if you just share your screen as well.
I think I might be having a similar problem. Like I've saved the file on my computer, but when I open it in the terminal, it's empty.
Yeah, so I have options. Basically, it says file name to write, colon example1.py. At the bottom of the page, this is. And then I've got options, Shift and G, get help, cancel, to files, DOS format, map format, append.
I think you just hit enter. Try just enter.
Oh, yeah.
Cool. Wonderful.
Well, that was easily solved. Thank you.
So Amelia, you're also struggling to save the file?
Yeah, it's saved on my computer, but it seems like the like Jupyter and the file system in my computer aren't really talking to each other properly.
Can you share your screen?
Yeah,
I think that would be easier to document. Did those of you
someone else is sharing at the moment, so
oh, I am sharing, yeah. There you go.
okay, so okay, can you see that? So
Yeah.
that's the file saved in Notepad++. It's in Software Carpentry 2 Python scripts. So I've written it up. Then if I not that, sorry, not that. Oh God. Apparently that's just closed itself, which doesn't fill me with confidence. Sorry, my Chrome's just crashed. So shall I just try and get that back? And so I stop sharing.
I mean, I'm also struggling with way too many windows at the same time.
Let's try this again. It might just work fine now. I guess it might think.
Well, but then that is the perfect classic. Here, I'm trying to show you how it's not working, and then it works brilliantly. That would be the easiest.
Don't want to show you all my
Google Drive, so. I don't need to see that.
Has it come up yet? No. Come on, Jupyter Lab. You can do it. Where are you? Oh, everything's just gone wrong. I tell you what, I'm just going to stop for now and let my computer come back to life. And you carry on and I'll catch up. Oh, no, hang on. I've got something. Okay, so we were in we're in desktop. What have I done? Software Carpentry 2 Python scripts. Oh, can I just open it? Okay, it's there now.
Yeah.
So we might be all right. I'll try it.
Try and run it.
So I was in. I'll just run it from here.
So if you now, yeah.
So.
Yeah, so you need to navigate to that exactly.
All right. Yeah. So first of all, it's doing this fun thing when Nano's like writing over, like displaying over the top of whatever.
Yeah, I mean,
but you can see there's nothing. If I exit that, I'll clear and try again.
But so what's in that directory? Okay. Yeah.
So that's the problem, because then when I run whatever I .py and it runs fine, but it's because there's nothing in there.
That is very. Can you close Nano again?
Yeah.
So if you ls, there's nothing in that directory.
Whatever I .py is in there.
Okay.
And it is, in theory, it's this, because that's in the same place.
Yeah, but so can you just type Python and see what happens, or if it's just literally
just that
So Python and then space waf writer.py.
I think what happened last was it just ran it because there wasn't anything in there, so it didn't have any errors.
Has it definitely been saved from the other editor, text editor?
So
Yeah, I mean, we could see the.
it's not like we've got its little star.
Yeah, I'd recommend closing that file and then opening it again, just as a sanity check.
Okay, so. So did most people get to the error bit?
It's not in there. Sorry.
I can't even get Nano to work on that PC. It seems to just hang the terminal.
I'm going to stop sharing.
Yeah. So can I get a show of hands who managed to do it and who's struggling, so we can kind of get everyone to the same. Maybe red crosses for if you can't get it to work for whatever reason.
You remind me what the error message is that we should see.
So we should see something, name error, name tau is not defined. Because effectively the exercise for those of you who do manage to run it and get that error is to figure out how do you fix that error. And the hint is
Would you please tell me the error again?
So it should say name error, name tour is not defined. I can just share my screen again and show you. So if you get to that point and have a little look around the Etherpad, you might find.
So tau is not defined here. So we have to define what is tau.
Yeah, but so tau is it's like a special it's like pi or something. So
np dot tau, or if it is now in NumPy.
Yeah, so it's yeah, if you take a look at line, so yeah, so we were looking at line 225. If you look a little bit later on, line 384 onwards, there's something very similar there, and you might figure out what the missing part is. I mean, basically, this is supposed to be an exercise in trying to figure out errors and how to deal with errors, as well as running a script from a terminal. So who's still struggling to get the script even to save in a file? Amelia, you managed to do it?
Yeah, it seems to be okay now.
Cool. So who's not managed to not get to the point where they can type Python example.py?
Me.
What is your problem?
When I type in nano, it works from the PowerShell, but it doesn't work from the terminal in the Jupyter Lab. It just hangs and then closes the terminal. I can show you this on the screen.
Yes, please share your screen. Let's figure that out, because.
Not share screen, not,
Sorry, I need to unshare. I just need to stop sharing. Sorry. There you go.
All right. So can you see that now?
Yeah.
Okay. So if I just type in nano example.py. I enter. then that happens.
And if you, so you said it works in the PowerShell?
Yeah, I think so.
Well, I mean, I guess in the end, we just like if you can work from the PowerShell, that works too. I think it's just a matter of can you get to the point where you can type Python example.py?
And should that be the same working from the PowerShell?
Yes, I think that should work in the same way, assuming you have connected your Python to that somehow. But I'm not the Windows expert. I've not used Windows in so long. So someone who actually knows about Windows might be able to help more here.
Yeah, I'll go try this week. Give me a couple minutes to let you know.
Cool.
Might I also suggest that like Nano is also just a convenience as well. Open any text editor, Notepad, not Word, anything that will just deal with text, Notepad++, and you're fine. Nano is just something nice and handy that gets you straight there if you need to do something quick.
I think as well on that topic, I think the reason mine wasn't working is I had it open in two places. I had it open on Jupyter Lab and in Notepad++. So also maybe watch out for that.
Yeah, so I've just copied two text editors I frequently use into the chat, which are Atom and Sublime. They're probably my favorite two to work with, but or VI, which is not super super user friendly, but if you're only working in a terminal, then that is also helpful. But yeah, I think sometimes just getting VS Code is also good, but not if you're on a Mac. So there's many, and for Python, I would, I think we already discussed this. I would highly recommend PyCharm because it really makes developing anything a lot easier. So, but here's a perfect example why actually these Jupyter notebooks are fairly straightforward to use and easy to use, whereas actually just running a simple Python script in a terminal seems to be much harder for everyone to get to a working state. So I will carry on with this. So I have my example, and my example gives me this error. I'm going to use VI because this is my preferred way of looking at a file. So it's trying to, so there's this bit tor here that is undefined. And then actually what I notice as well, just looking at it here, there's a sign function. And if I go back to the top, I'm only importing something called struct and something called wav or wave. If you remember, we used the math library to import things from there before, and sine and cosine and pi are part of the math library. So actually the sine bit will probably also fail. So in order to fix the script, we need something like from math import tor and sine. And then if I try and run it again, it now runs without an error. And I have a WAV file that was now generated, which I can open. And now it plays this lovely sound. I'm not sure if you heard this, but. So that is effectively how you would run a Python script from a terminal. rather than in a Jupyter Notebook environment. And as we move forward today, I think I will ask you to create a couple more scripts in a terminal environment. Oh yeah, so I was quite fast with the import. Yeah, so it's from math, import, tor, and sign. And particularly if you start writing scripts, you will soon realize that it's super helpful to have an IDE that does help with some syntax highlighting rather than working in this environment. I would not recommend writing a script in the way I've just shown you. This was just more we're copying, pasting, and using the Jupyter Lab environment to get to the terminal. In the hope that everything is contained, and then we still had some errors, which is always fun to deal with. But yeah, but this is kind of the very simple way of writing your first script. And we have a little bit of a look at what actually happens here. So I think yesterday I was talking about how to document things. So this way of documenting is slightly different to the NumPy way, but it still uses these sort of triple quotation marks and defines parameters rather than saying parameter and then a long list of explanations. It uses param as this is a parameter you need to give, and it explicitly tells you that this needs to be of string format or list and what type of integer and so forth. So this defines your function that writes the audio to file. There's some excellent audio processing bits. I'm probably not going to pretend that I fully understand what's happening. But effectively, what then happens is, oh yeah, so what you do here is you open your file, then you set a bunch of things for your WAV file, and then you actually write the file here, and then you end up closing it at the end. And then in order to run it, you need to give it a bunch of, so here the write audio to file takes a bunch of input. And that information is sort of created here as a sort of global variable environment. And then you generate your sample and basically give it a file name and pass the sample to that file you're trying to write, and then you get your file written out. So that's my very crude understanding. Maybe Matthew could explain this better, but yeah, that is kind of okay, we've now written a script and we have executed it with the command line. So yeah, as I said, I'll probably come back to that later. But for now, I would like to go back to a Jupyter Notebook environment, and we're gonna cover effectively 3 topics I would like to do. One is formatting strings, which wasn't on the wish list, but it always annoys me that it's not part of the curriculum for some reason. Then Numpy arrays and classes. So I'm going to just close this and start a new notebook, and I'm going to make this a little bit smaller. And move this over. So if everyone could open up either a new notebook or a notebook they want to continue working in, then yeah, please go ahead and do that. So I just call it day 4. And the first one I would like to talk about is string formatting. So depending on what you've learned before in terms of programming, you may have come across different ways of formatting strings. And in particular, I mean something like, oops. So I can type something like print hi there, which is simple because we just have a string and we pass that to the print function. But what if we have a variable element name equals carbon, and element mass equals 12. I can now print something like we know about element name okay, so I can print something like we know about carbon that it has mass 12. However, the way I do this is quite awkwardly, so I need to convert my well, for sure the element mass to a string, and basically have to create this awkward string to do the printout. What if there was a different way? So you may have come across this % formatting, where well, that's quite common in C, I suppose that's where it comes from. So I'm just going to copy this print statement and say, rather than using this plus addition for my string, I can simply say I want a string character here, or a and a integer character here. And then I can use this % element name element mass after, and I get the same printout. And what it does, it kind of replaces this variable name for my string here and this variable name for my string here. So this is a very old school way of doing it in Python, and giving such a simple example, it is still readable. You can kind of just about make out that I'm supposed to be replacing this variable name and this variable name in these two places. But what if you end up with a string where you have, I don't know, 5, 6 variables you want to replace, and then suddenly things become quite messy. So instead, what is nowadays recommended is using F strings. And F strings are something that came in Python 3.6. And yeah, you don't really see them that much yet, particularly if you look for older things. Well, not necessarily look for older things, but if you look at Python tutorials, you often still see this kind of string formatting. That's why I kind of wanted to introduce this different way of formatting strings. And the way that works is that you can explicitly put your variable names in rather than having to use this very awkward %d and %s way of presenting it. So print, and I said it's an F string, so you need to put an F in front of the string you're trying to print. And now I'm gonna just copy and paste this. But instead of having %s, I can now use curly brackets to say element name. And element mass. And I again get the same answer, but now I know exactly where I put what variable in my string. I don't need to worry about some awkward casting to string if I try and give it a integer. Yes, you can definitely, yes, you can do display precision with F strings. So I'm trying to. See if I can, sorry. Yeah, so let's have a very simple example at how to format F strings in terms of how much floating points or something you want to display. So I can say pressure equals 1.05. And then say I want to print my pressure as an F string. well, maybe 0, 5, 7, 8, something like this. I can say F pressure, and then I use a colon, and then the same kind of formatting as you would use for your percent formatting. So that makes it, let's say 2 floating point numbers, and then it rounds it to your 1.06. So yeah, the syntax is effectively colon dot, and then what you're used to from before. And this is kind of the modern way of doing f strings or string formatting in Python. So that is the first topic. This was kind of more of a small rant for myself than things you may have asked for, but look at how to do string formatting with f strings if you want to format strings. So yeah, the next big topic was Numpy arrays and how Numpy works. So I will, yeah, in the next sort of 15, 20 minutes, kind of give you a very broad introduction to it. And then there are a bunch of tutorial questions for you to try probably after the coffee break, I would imagine. So yeah, let's get started with Numpy. Okay. So Numpy is a numerical Python library. It has lots of different useful things in it, and I'm kind of just going to give you a little bit of a flavor of what kind of things you can do. There is a great page which I'm going to put in the chat, which is Numpy for Matlab users. So effectively, it discusses differences between Matlab and Numpy, but also how, but also the similarities, as in a certain functionality you have in Matlab probably also exists in Numpy, just with a slightly different syntax. So absolute basics, we start with importing it Numpy as NP using this alias, and then we can very simply define a one-dimensional array. A is NP array. We're using round brackets, and then inside basically we stick a list 1, 2, 3, 4, 5, 5. We've now defined our first Numpy array. So again, super key difference between Matlab and Python. So A square brackets 0 gives you the first element of your Numpy array. For a Matlab user, the same should be this. Then, yeah, as we kind of progress to sort of matrix multiplication type of things, we will see that Numpy arrays don't by default do matrix type multiplication, but do a element by element multiplication. And if you do want a conventional matrix multiplication, you need to use different operators, which we will touch on in a little bit. And I think the other main difference is that if you do any kind of slicing in NumPy, is that you're passing by reference and you're not copying the arguments. So if you do a slice, which we'll also look at in a bit, you are basically creating a view on the array and you're not copying the array. Okay, so effectively, we've just created our first NumPy array. NumPy arrays have kind of useful built-in attributes. And these are things like the dimension of the array. Oh, sorry, not. So the dimension of A is 1, then the shape of the array, so A.shape. The size of the array. Which is a bit like length for an n-dimensional array. For a, so if instead of using len on a list, size kind of gives you that. For a one-dimensional array, that'd be the same. For a multi-dimensional array, it'll give you the total number of elements in the array. And it's equal to the product of the shape of the array, but we'll look at multiple dimensions in a second. Then you have information on the data type in the array. So that is a.dtype. In this case, it's integers, and they're of type int64. And then there's something I don't really use very often, is a.item size, which gives you information on the size of bytes of each element of the array, effectively. You might have a 32-bit processor. That would be my, I have no idea why yours would default. Intriguing. I have no idea. What version of Python are you using? Maybe that hasn't, or the NumPy version? No, I have absolutely no idea. This would be one for Google. Maybe Windows, yes, sure. I mean, there probably is a reason somewhere, but I don't know.
It's for either the processor is 32-bit or the Windows is 32-bit.
Ah, okay. I mean, something needs to be 32-bit clearly for this to be a thing. Yeah, so these are the kind of general queries about a array you can make. Then the next thing we can do is actually look at it in multiple dimensions. So I'm gonna redefine A here as a multiple dimensional array. So rather than having to type 1, 2, 3, 4, 5, I can also use the so-called arrange function. So np.arrange 15 will create me a one-dimensional array with 15 with numbers of 1 to 15 in it. So 0 to 14, because we start counting at 0. the you can now change the shape of that by using the dot reshape function on it, and say we want it as a 3,5 array instead. And now I have 5 columns and 3 rows. So I've now just changed the shape of my array. And now if I look at my dimensions, I have 2 dimensions. My shape gives me more information. I still know that I have 15 elements. I'm assuming my data type is still 64 and the item size is still the same.
Can you just scroll back up a little bit so
Yeah.
I can copy the reshape bit?
Sure, sorry. Sorry, someone's at my door. I'm just going to quickly open the door.
Well, Tony does that very quickly. The key to the mystery here is for the 32-bit data length instead of 64, is that a long is 32 bits in Windows, which is one of the dangers if you're C programming of not specifying exactly the number of bytes that you require. There we go. There's a link. Go check it out if you're interested.
Thank you. Yeah, but so NumPy does figure out types automatically. So if I were to say b equals np array of 2.3, 4.5 and b dot d type, it now gives me a float 64 because there are floating points in there. You might get a little bit carried away and accidentally type something like b equals np array of 1, 2, 3, 4, and that will give you an error. Oops, sorry. I mean, this also gives you an error, but for a different reason. So in fact, array takes from 1 to 2 position arguments, but 4 were given. So I need to give it a list. So if we look at the doc string, it tells me that I need to give it an array-like object. And the other thing I can give it is a data type, for example. And then there are a bunch of other things I can also give it, but yeah. So that it's important that you give it some kind of sequence array-like thing for it to be created. And this is not a sequence or array-like thing. So I do need my square brackets around this. I can also explicitly define a 2-dimensional array rather than using the arrange. So I could say something like p equals np array of 1, 2, 3, comma 4, 5, 6. And then b dot shape is now a 2x3 array. And yeah, I now have a 2-dimensional array created. I could, for example, if I wanted, say I don't want integers, but actually I want a data type that is complex. I can state that explicitly, and now my array actually has complex values in it and is no longer an integer array. So then if we kind of go back to the arrange option, so you don't have to just simply give one value, but you can also say C equals NP arrange 10, 30, and 5. Well, sorry, I always misspell arrange for some reason. And now I get a stride of 5 within a range between 10 and 30. I can also give it floating point strides. So I could say something like 0.5, and then I get an array with, yeah, many more entries. Another similar yeah, so sometimes arrange isn't so ideal because it might not be possible to predict the number of elements obtained due to finite floating point precision, particularly if you're using floating points as steps. So instead, you can use a function called linspace that receives the number of arguments, where you can specify the number of elements that you want instead of the step size. So I could say something like np.linspace from 0 to 2, and I would like to have 9 numbers, and then it kind of figures out what the linear spacing for this should be. And it's very useful to kind of, particularly, linspace is very useful if you want to evaluate functions. So if you have something like x equals np.linspace 0, 2 times np.pi, and say 100. And then I can say f equals np dot, and then I've now got values for f, and I can matplotlib dot pi plot was it matplotlib pi plot inline?
Yes.
No, that is not correct. Okay, this is one you should not be using, but Pylab inline will work. And then I can just say plt.plot xf. No, apparently not. Well, that would. Interesting. That should. Did I just accidentally? Okay, so yes, actually what happened is that the Pylab overwrote my f, which is very exciting. So now I can plot sine x and sine function. Okay, let's get rid of this. Okay, so effectively I've now generated a bunch of x values and then evaluated that function, the sign function at these x values. And now I can very simply pass this to my plotting function to get a nice plot of a sine curve. Yeah, so in terms of printing arrays, we can do again things like a equals np dot arrange 6. So a one-dimensional array, if you pass it to print, will be printed as a row, effectively. A 2D array equals np arrange, let's say 12, reshape 4 and 3, and then print b. Okay, I don't know why I really insist on spelling arrange with 2R, but in my head, that is how you spell it. So for your 2D array, you do get it printed as a matrix. And if you were to do the same thing for a 3D array, you can do reshape. You can do the same thing as before, but now you give it 3 dimensions for the reshaping, and then it prints it in these nice blocks of 2, effectively, of your 2 3x4 matrices. Yeah, let's talk a little bit about operations in, yeah, we'll do operations and then we'll break for a coffee break. So if I have a simple array 10, 50, 10, and b equals np arrange. So we have a and b. If I wanted to do any kind of operations on this, it will always be an element-wise operation. So I could say c equals a minus b. And then you basically take element 0 of array B away from element 0 of array A, and so forth. The same applies to multiplications. So I could say C equals B to the power, B to the power of 2. So each individual element gets now squared. I can do a scalar multiplication with a single factor. So I could say 10 times b, and that will just multiply each value in that array by 10. Yeah, and then you can also do similar to the masking we talked about in with the pandas. You can get information on whether something is true or false in an array. So I could say something like a smaller than 35, then it tells me whether that is true or false for each single element. All right, I think I'm gonna break here for a little coffee break until 10:30. And then I think in the chat, you're already kind of way ahead of what I'm trying to do. So we'll get to matrix multiplications and element-wise products and so forth now. Yeah, some more advanced topics with Numpy arrays just after the break. And then we'll also look a little bit at how to write a class in Python. Yes, we can talk about axes. We can definitely talk about axes to clarify column and rows. But I'm gonna I hope you managed to get a nice tea or coffee or some water and some generally refreshment from the screen. So yeah, let's carry on a little bit with the NumPy parts. So let's look at matrix multiplication, either element-wise products or matrix products. So let's say A equals and 1 1 and 0 1. And let's define B as something like NP array of two 0 and 3 4. So if you want to do an element-wise product, we just type A times B, and then each element gets multiplied. If we want a matrix product, we can use the @ key for this, and that will give us a matrix product, or an older way of doing the same thing, using A dot B. That's how you do your sort of very standard matrix multiplications. Then yeah, there's different ways of initializing your array. So say you wanted random numbers, for example, you can, well, actually, let's start with 0s and 1s. And I think this was already kind of mentioned in the chat. So you can initiate an array with 0s. So np.array, np 0s 10 will give you an array of 10 zeros. Ones is NP ones, and that will give you an array of 10 ones, and then you can easily multiply them with whatever you might want in order to get numbers in there. Let's look a little bit more at how to select columns and rows in arrays and how to do operations on columns and rows. So let's take a array A equals NP arrange 9 reshape 3 3. Classic typo. So if I wanted, so A is this, if I wanted to select a column, I can use the slice notation. That gives me the 0th column, then I have the 1st column and so forth. If I wanted a row, I can just select the row index from 0 to 1. So this one will give me this the second row in this matrix. This is also a way in which we can operate on the data within it. So I could obviously take A1 and say NP sum of A1. This is something I can write, or I could use the axis option and say but that only gives me the sum of this row. But what if I want all the sums of all the rows? I can use NP, oh sorry, not NP sum, A dot sum, and then something like axis 0, which will give me the sums of all the columns, or axis 1, which will give me the sum of all the rows. The same thing works with mean or standard deviation. So there's many different options in terms of how to operate on your rows or columns of your data. Yeah, then yeah, I suppose the slicing is something that yeah, I mean the slicing kind of works similarly to the slicing of your pandas data tables. So yeah, you can take subsets of an array, but then that is just a view of the array and not a copy. If you wanted to copy an array, you can do something like does that not work? Yeah, so if you wanted to copy, you can do copy or a deep copy. Which is it this one? Oh, okay, maybe it's deep copy. No, there's a deep copy. What's the deep copy? Anyone know? Okay, I can't remember. Anyway, yeah, so there. So a deep copy, deep is true. Yes, that is, thank you. So basically, this is something to do with the way the memory is allocated in your computer. So you can have a shallow copy that I think is effectively just a reference, isn't it? Whereas a deep copy actually creates a new array in memory. What you can also do is yeah, I don't know. Is there? There's lots more things we could talk about probably. Anything in particular that might be useful to look at?
Could I ask about the 3D arrays?
Yes, yes.
So earlier on, we did a Numpy array range and then reshaped it to 3 dimensions.
Yeah.
And it looked like the first one was kind of what I call pages. So there were like 2 pages, and then each of those pages has rows and columns. Sometimes people call them slices. So is it? I would read that as the 3rd dimension, but it came first in the list when you gave it a reshape. I just want to make sure I've got the axes of which one's which.
So that would be the first dimension in. So if you have let's go with A equals NP arrange 24 dot reshape 2, 3, 4. So the first, this is your first dimension, so that is your 2 pages, I suppose, and then you have your 3, 4 matrices in there.
Okay, so in Matlab that would be dim 3, but in this it's dim 1.
Yes.
Okay, thank you.
Sam, I don't know anything about speeds of row versus column iterations, actually. If you know something about it, then...
Okay, so this actually ties into the stuff that was just being said about how Matlab has like the dimensions are kind of a different way around. So Python stores the data in memory in the same format as C, essentially, where it's the last index that varies the fastest. So going from, the bit in memory that is sort of 1, 1 is next to the bit in memory that's 1, 2. Matlab stores it in Fortran style, I believe, where it's the sort of the first dimension that varies the fastest. So in Python, the last dimension is the fastest to iterate over. In Matlab, the first dimension is the fastest to iterate over. And you can, if you have large arrays with multiple dimensions, getting it the wrong way around can mean a factor of 1,000 difference in the time it takes you to iterate over an array, for example. So you kind of, if you're going to be going in a 2-dimensional array and iterating over 1 dimension and then another dimension in like a nested way, you always want to do the last dimension in the like furthest down in the nest and then go up progressively outwards that way. I'm pretty sure. I can try and give a little example in the chat, but yeah.
I can. Yeah, if you want to create an example, I can do a little bit of linear algebra and then we'll go back to that example. Does that make sense? Because that gives you time to create it.
Yeah.
Cool. So yeah, I suppose in terms of linear algebra, you might be interested in doing some very basic linear algebra operations. So I'm going to do a sneaky copy paste of this. So let's define another 2 by 2 matrix. 1, 2, 3, 4. Again, I can do a transpose of this by just typing a dot transpose. That gives me the transpose. Then I can look at generating a identity matrix. An identity matrix, let's call it I equals NP I of 2. And that just gives me the diagonals as 1. I can look at a trace of a matrix by saying np dot trace of A. I can solve a well, I can look at the eigenvalues of a matrix by saying np lin alc, yeah, eigenvalues of A, and yeah, so there's a lot of built-in functionality for these kind of things. The other thing that might be useful is stacking of vectors. So say I have something, let's call this stacking. So X is Y. 0, 10, 2, and Y equals NP arrange 5. I can got a bit carried away there. So I can now horizontally or vertically stack my 2 vectors. So let's say M equals NPV stack X and Y, let's call it V. And I can horizontally stack saying H equals NPH stack X and Y. And then if I look at them, I've now got 2 vertically. So if I look at the shape of this V dot shape and the shape of this, you can see how they are H. Yeah, so basically the H stack in this case just adds onto the end of the vector versus the vertical stack kind of puts. Yeah, and then there's a lot of sort of built-in things like you can easily get a histogram out of Matlab, Numpy, and then plot that. And yeah, there's just a bunch of other things in general available. What I quite like is there's this linear algebra n-dimensional arrays tutorial, which I remember was one of the first tutorials I looked at, and I quite enjoyed it. So I'm just going to pop that in the chat. And I would effectively just have a look at the NumPy documentation online. There's not really exercises per se, but there's a lot of examples of how things are done, and just looking through them can be super helpful. Sam, how are you getting on with?
Sorry, I was attempting to get a timer working, but that's taking longer than I'd hoped. So I will just cut that out and give the example code. Oops, that is in fact. I had the wrong index there. There you go, that's better.
Okay. And you wanted to time each of these?
Yeah.
So not just import time. And then, well, I can't remember how to time things either. I always have to use
It's
time, Python.
Time now.
Okay. Big equals time now. Like this. That should be end. Okay. And then let's have a look at the slow version, if this is actually slower. I think that's too, that doesn't seem to make a difference. If anything, the slower version is faster than the...
Oh dear. Okay, maybe it needs to be bigger, or maybe I've got the other way around, but there is, it does matter. It's annoying because this isn't the sort of thing I do in Python, but it is the sort of thing that can be a problem if you do it in Python.
Right. Yeah, I don't know. Let's, one last try, and then let's move on to classes. Yeah, no, you're right. So now the fast version is faster than the slow version. So I suppose, and this is only 5,000 by 5,000, so it can get a lot worse. Okay, let's move on to some classes though. There's a bunch of exercises available for NumPy if you wanted to Time it. Yes, I knew about time it. That is a very good point. Thanks. Yeah, so here's repository, a GitHub repository with Numpy exercises, which look kind of fun. I've not really done them. This was just me kind of finding things to do. But yeah, for the sake of timing, probably we don't necessarily need to, like, I would encourage you to have a play around with NumPy in your own time to try and use it for a problem you have, and yeah, play around with it. Let's get to some classes. So classes in Python. So classes are very useful if you kind of want to group things together that should belong together, and you want to access those kind of attributes. So I don't know, a classic example would be shapes. And so you could have a class such as triangle, and the triangle could have functions in it that would compute the area of the triangle, or give you information on the angles of the triangle, and so forth. So basically you're trying to group things together that work well together to then access that information in your code. So the way you define a class in Python is by using the identifier class, and then typically you would use a capital letter. I'm going to give an example of a geometry thing. So let's call the class square. And then you use your colon, and then what every class has is an init function in it. And the init function basically is the instantiator, is that how you say it, of this class. So if you create an object from that class, it will run the init function. So every class you create needs to have this underscore init function in it, and then self, and then here you have the body of that init function. So in the example of a square class, we might define something like give it the number. No. So in this init function, we will define any kind of member variables in that class. No, that's so not true. We can define member variables in this class. So a member variable would be indicated by using the self identifier, and let's call this variable sides, and in a square there are 4 sides. So now I have effectively defined my first class, and I can now instantiate an object of that class by saying my shape equals square. Square, not spare. And I've now got an object of type square. So my shape now tells me that this is of type square. I can call this member variable sides by typing something like my shape dot sides, and that will return the value that is stored within this class. I can pass information to that constructor and say I would like to, I don't know, pass it a length, and the default length is 1. So that means I can still call my my class in the same way. I don't actually need to pass the length variable because I do have a default set. But if I wanted to, I could say length equals 3. I mean, at the moment, length doesn't really do anything, so I should probably define another member variable saying that I want self dot length to equal length. And now I should have access to this length. My shape dot length now tells me that it's 3. All right, let's see if we can define a function within this class that gives us the area of the square. So this works very similar to defining a function anywhere else in any other scope. It just means that the function only lives in the scope of the class. So let's say def area, and by using the term self, I tell it that this is a function that belongs to this class. And then I can say return self dot length to the power of 2. If I now instantiate the object again and say I want to print my shape dot area, I will get the area of my square back this way. Yeah, I think that is probably the main gist around how you define a class, and how you would initiate it and then access members of that class by using this dot notification, not notification, notation, there we go. So I suppose one way of hiding, I don't know, let's see, okay, let's go with it. So we were talking about these underscore variables from before. So if you want to kind of hide away certain member variables in your class because no matter what you do, you'll always be able to see the member variables in Python. So in C or something, you can declare something as private or public, whereas C++, I suppose. Whereas here, it's always accessible. But you could say, actually, I don't really want people to be able to access length. So I'm going to define it as a variable that is supposed to be hidden away effectively. And then I don't really want people to be able to look at it. They can still look at it, but it won't be as obvious. And then if I wanted to use this, I can run, yeah, I can initiate things again. And then if I now look at my shape, I have area and sides, but I don't really have length as an option anymore. I would actually have to get all of these underscore options or look at all of these underscore options. Is that not right? Is that not how you do it? Am I getting this wrong? I'm totally getting something wrong. Sorry. No, it's not. Yeah, it's 1 underscore, not 2 underscores, I suppose. Sorry. Yeah, okay, sorry, don't use 2 underscores. 1 underscore is a way of hiding things. No, 2 underscores. Oh, I just had a typo. Ugh, never mind. Everything's good. I suppose, yeah, 1 underscore, 2 underscores effectively hides things. You can do whatever you want and then type things correctly. So yeah, in this way, you just don't have that information visible in your environment you might be programming, and that usually tells you that you probably shouldn't be accessing that variable directly if you're working with that class. And typically, yeah, and that is effectively a way of hiding things. You can do the same thing with a function as well. So I can say def get sides as a function, and somehow I don't really want get num sides. I don't really want that to be public. I can just say return self dot sides, and then that function will be accessible but is hidden away, and I would have to use the underscore in order to access it. I think, so I have prepared a little bit of an exercise for classes, and maybe I can leave these up here. So effectively, here's the instructions of, we're trying to write a class around a triangle. You need to define the init method, and you should be able to give it angle 1, angle 2, and angle 3 as arguments, and then create a variable named number of sides and set that to equal to 3, and create a method that checks angles to make sure that the sum of the angles is equal to 180. And then basically see if you can get that to work. So I will leave this up and you can have a go at writing your own class. How are people getting on? Do they manage to create a class? Cool. Yeah, Andrew, feel free to move to exercise 2. So this is basically making use of the if logic we used yesterday to test inside a class. And then, yeah, there's obviously a lot of sort of architectural things you can do around classes, so you can inherit from other classes, and yeah, but these are very much in terms of how do I design my code to do what I want it to do. So this is not, yeah, there's a lot more design questions around it than the syntax itself. So I think maybe one last concept in terms of classes of why you might want to not have a public attribute that you can easily change, because effectively if you instantiate something with length, I'll answer that question in a moment, but so if I have length set in this way, in my example here, I can, in theory, just change length to 4 if I wanted, which might not be something that is super desirable. And in C, C++, I suppose you would have something like a getter and a setter for changing the value of a member variable in a class you initiated with your constructor. So in Python, you can use properties, and for example, length might be a good variable to use a property for. So what you would write is something like this at property def length self, and then return self dot underscore length, which at the moment won't work, but if you now use a setter here, so rather than, I mean, we can leave the syntax, but effectively what will happen is something length dot setter. So we're setting length self and length. If length smaller than 0, length, self dot underscore length is 0, because a length can't be smaller than 0, and else self dot equals length. So now I basically the same functionality still applies. So I'm effectively assigning my length, but now it actually uses this setter rather than just a direct assignment. So if I now go and change my length to -1, my shape dot length is 0. So I can basically check that whatever assignment I make afterwards is sensible, but without, yeah, I can basically make sure that I don't accidentally manipulate a value of a variable in my class that isn't allowed to have that value effectively.
Sorry, I'm just a little confused. There are 3 different underscore amounts in here. I don't know if is that so there's a single
it should always be 2. Just just ignore the single one. It should be 2.
And the first one as well.
The first one as well, yeah. So but basically if you use 1 or 2, it hides it from the standard available output effectively. But yeah, so I think 2 underscores are usually sort of built-in functions like init, and there's a bunch of other ones. So if I look at square,
I was just looking this up because it's pretty crazy. There's a sort of funny sort of thing where if you put 2 underscores, then the class name becomes part of the way it's referenced, so you can overload them
Yeah. So all of these underscore ones are either functions or instances within that class, and you can do lots of interesting things with that. I don't ever do. And yeah, you can do a lot of overloading. You can, yeah.
So those the functions that's kind of been created by default, essentially.
Yeah, so whenever you create a class, you basically create, I don't know, like you can explicitly say square is of type object, for example. And then object has certain attributes to it, and you can then override and manipulate these. But I think if you do basic analysis and scripting, you probably don't necessarily need this. I think the only thing, like something like this, you might find useful. I don't know. Yeah, you probably might find use for this, but this is not something I routinely use.
The other thing that surprised me there was your, so the sort of self dot sort of, well, you were calling them variables, weren't you? I mean, I'd have traditionally called them properties, and I would have expected to define them at the start of the class definition before you did anything else. But you seem to be able to just kind of
so you can also have a variable here, so that is perfectly fine, right? So you can say var equals 10, but var equals 10 is always accessible to any instance of the class, whereas anything you define in here is only available to the object that was initiated with the constructor.
So the ones at the top are static?
Pretty much, yeah.
Okay, right, I see. Oh, great, okay. I have to reset my brain. This is quite different to what I'm used to.
Yeah.
And then the property that you've got there is what I would have referred to in my mind as a kind of method masquerading as a property, and the sort of thing I'd have used inline sort of coding to do in C, where you
so for me in C that would be a getter. And rather than, because you just get whatever value of that variable, right? And but I don't know, my C is a bit rusty now. I haven't programmed in C for a long time, so I might not remember this.
Well, I'm going to say, to be honest, I've mostly been writing classes in Matlab recently, so that probably...
Fair enough. I've never written any classes in Matlab, so I have no idea. Yeah. And it's been a while since I've written a class in Python as well. But yeah.
Thank you.
So there were a bunch of questions in the chat. Have they been kind of resolved? Do we want a discussion of the exercises? Did everyone kind of manage to write a class that works? Yeah, cool. I get thumbs up. Excellent.
I was slightly surprised because I tried to use the check angles function within my constructor, within my init function, and found that always spits an error. So I don't know why. Having made an instance of the class, I can then call that function no problem. But if I actually try and put it in the constructor to check those values as I create it, then it doesn't work. It just spits some sort of, it says it's not defined, despite it being listed first. Did you use
self dot? So if you wanted...
No, I didn't. Okay. Oh, I did check angle self, but then that might be my MATLAB.
Yeah, so if you wanted to if you want to use a method in the constructor, you need to go self dot area, and then that should work.
Thank you. That's me doing MATLAB syntax in Python again.
No, that's fine.
Thank you.
Does that work?
Yeah.
Cool. Yeah, I guess that is it for Python. I hope the slightly more advanced topics were helpful to you guys to get a bit of an idea of what you can do. And yeah, Numpy is a great library. You can do a lot of things with Python. usually someone else has done it before you. So before you go off and write lots of classes on something, maybe check if someone has conveniently provided a package for you already. Yeah.
Is it all right if I just say something? Because Alex was kind of asking me.
Absolutely, yeah.
Is Alex here? I'm not even sure.
No, I don't think so.
No.
She's not here today. She's busy.
Yeah, so I'm kind of busking it here, so apologies, everyone. Yeah, Alex, we were just talking. So one of the kind of drivers from the UCAN computational acoustics SIG side for running this workshop is the increasing amount of open source software that is Python based. And I mean, obviously there's a lot of sort of scripted things I've been writing today, and obviously a massive increase in the use of sort of Jupyter notebooks for online documentation and tutorials and all sorts. So I've often seen them and never had time to look at actually work out how to write one. So this has been really good. But I was just going to point out that, I mean, one of the main drivers is Python as a kind of scripted interface for other things. And the three examples that we've been looking at, obviously, Matt gave this great example for audio handling, but there's some fantastic examples of open source libraries developed by members of the community that have a Python interface.
Mm-hmm.
So one is Gamesh for meshing, so you can kind of mesh objects and create meshes for finite and boundary element method, and that used to all be text scripted, but recently they have a Python API as well. And then there's BemPP, developed by Timo Becht, which I know some of you will know, down in UCL, which again is, I mean, they've changed the underlying processing and coding of that a couple of times, which keeps confusing me when I try and use it. But the interface is Python based, so you build your own sort of mathematical operators and things in quite a sophisticated way. But you just script it in Python, and then it calls all these libraries that have been compiled and optimized. And the same in Phoenix as well, which is a FEM package. So I think that's an emerging trend here. Is that not only can you script things, but it's kind of it's used as an interface where you're writing script and it's actually calling some quite sophisticated, large scale, high performance computing libraries underneath. The other example I've seen, actually, also just last one, just in industry, is I've seen it also being used to access things like GIS databases. So if you want to get geographical information and things like that, there's now seeing that there's often Python APIs for those as well. And that then means that you can, rather than just of hacking manually, you can script the way that data interfaces. And I've heard quite a few people in consultancy describe Python as glue, kind of coding glue for different databases and different systems, because so many things, with it being open source and free, so many things now have a Python interface, and you can kind of glue them together to make your own application or your own thing quite successfully. So I've seen people doing that as well. So
yeah, that's pretty much what I've been doing. So I've been involved in writing a Python library called BioSimSpace that links together different biomolecular simulation packages and make them interoperable and provide a uniform framework without having to bash script and do lots of intricate single steps that are brittle and not very easily shareable. So yeah, I think there seems to be a general trend to kind of have nice, sleek APIs that really allow fast production of complicated workflows.
Oh, and while we're at it, I'll just mention that we're also organising a summer school on computational acoustic methods, which I now have a date for, and I have a firm date. It's going to be the 5th to the 9th of July. It's not been announced yet, but that'll be another UCAN thing. It's been organised with the European Acoustic Association as well, but it'll be free for UCAN members, and that will hopefully be Python based. I was just talking to Matt very briefly about this yesterday, because
Mm-hmm.
I think that there's a few solutions there, but certainly people like myself are one of the reasons I'm doing this workshop is to see how you rolled it out, because that problem will probably land on my desk.
Yeah, so maybe I can point you guys to the Python, the Carpentry's incubator GitHub repository. So if you were to want to promote Python usage in your community, it might be worthwhile trying to design sort of lessons around more community packages for this, rather than just this sort of very general, broad introduction to Python. And the Carpentry's incubator would be a good place to put these, so you could use effectively the templates we've been using for these lessons, but put your own design and content in there, and then make it available to others, but also making it very easy to run workshops that are specific to the acoustic, there we go, oh my god, community, I'm so sorry. Yeah, so again, this might be a good like Alex is a good person to talk to, or myself, or like any of the instructors really, to see how one could get a lesson in there, but I guess it would be up to the community to kind of design the content a bit more, and then you'd have very targeted material available to you, rather than, well, you can have the broad introduction to Python, then followed by the 2-day workshop on acoustics, specific Python things. So yeah. That
sounds like a very good idea, and the sort of thing that, if I can ever find any energy,
we should be doing. Totally. Yes, absolutely.
Write that down somewhere.
However, yeah, we are in the coffee break now, so I would encourage you all to take a coffee break, and then after the coffee break, the next topic will be Git. And I'm done with all the teaching, so thank you very much for joining me on my little Python journey, and I hope it was all useful.